Thank you, Sharon. Good afternoon, everyone, and thank you for joining us for this presentation. My name is Bob Glenn, and I'm one of the regional managers here at Teledyne ISCO. Before I hand over to my friend Steve, I want to share a few things about our company. Teledyne ISCO is located in Lincoln, Nebraska, and was originally founded in 1958. We are a true manufacturer, not just an assembly house. So when we say we are made in America, we mean it. We specialize in the manufacture of rugged instruments used by professionals in the water, stormwater, and wastewater markets to protect water quality all over the planet, and we've done so for 50 years, having invented the world's first automatic water sampler in 1971. Even after a half a century, we remain a world leader in the field of automated water sampling, and we remain committed to finding new and exciting ways to apply our products to safeguard the world's water. The use of our sample products and wastewater-based epidemiology studies geared towards early detection of coronavirus is just one recent example of how our products continue to be applied in our rapidly changing world. We thank you for your business, and we stand firmly behind our pledge to continue to build great products and provide great quality service and support to all our customers for many years to come. With that said, I'll hand things off to my good friend Steve. Enjoy the presentation.
Thank you, Bob. Thank you, Sharon. And I welcome everybody for taking the time out of their day to join us. The majority of the questions that we will be answering through the main body of the presentation were questions that were submitted in advance. We will be opening the floor, as indicated, at the end to any questions that you may have had during the presentation. And even if there is any questions that come up at a later point in time, I invite, and anybody is welcome to submit those questions to me via the email address that will be included at the end, as was at the front end here. Today, we're going to be covering a variety of topics that relate to winter season sampling. Those topics or the categories are going to be issues associated with the transport line or the intake or suction line, questions that relate to the collected sample that's in the bottle within the sampler, power related questions, questions that relate to the electronics or the sampler controller itself, and location of the equipment. The first section of questions relate to those that are associated with the transport line or the intake or suction line. The first question that we received was, how do I avoid intake tubing from freezing in overnight sampling? There are various degrees of risk associated with sample freezing in the line. One of the biggest characteristics that can have impact is the duration and the degree that we drop below freezing, and those will have an important factor on the level of risk associated with this occurring. If we drop to 30 degrees for 30 minutes, the risk is going to be low. If we drop to 5 degrees for 4 hours, the risk will obviously be much higher. A factor in this is how much of the suction line is exposed to open air. There is a measure of insulation occurring for the suction line and the pump tubing within the sampler controller, as well as the amount of suction line that is in the area that we are drawing sampler from, that may be several degrees warmer than the outside ambient air. The orientation of the suction line is very critical here. Orientation of suction line in any application should always be that the line is in a continual downward slope away from the sampler towards the source to fully drain the suction line between sample collection. In normal circumstances, if that line is looped or sagged or in an upward orientation away from the sampler, there will be water retained in that line. And in the event that we are in a winter freezing state, that water that is retained within that line, therefore, would be subject to freezing. So that would be issue number one, is ensure that the suction line is orientated in a fashion to ensure that as much of that water that is pulled up for sample collection is allowed to fully drain and empty the line. Measures that can be taken: we may need to do nothing if the risk is low. So for example, if we're occasionally at risk of having a sub-freezing night where it may be dipping below 32 degrees Fahrenheit, 0 Celsius for a very short duration, the risk may be very low. We may need to do nothing. On the other hand, if the risk is higher, things like wrapping the suction line with insulation, potentially routing the suction line through a sealed conduit so that the air within the environment that we're drawing the sample from, that again is likely to be warmer than the outside ambient air, will maintain a above freezing amount of temperature in that conduit and prevent freezing. In extreme cases, we can use things like heat tape, where we line the suction line and that heat tape warms the suction line and prevents it from dropping below freezing. The big problem here with ice developing in our intake line is that at best, we can find ourselves simply unable to collect a sample because the line has become blocked by the ice in that line. Worst case scenario, a section of that ice could break free, be drawn up into the pump, and when the rollers come down to pinch, in the case of a peristaltic pump, it can hit that ice and create a major shock to the gears, potentially stripping teeth, causing all kinds of problems. In the event that it's a vacuum sampler, that ice could be drawn into and impact check valves or mechanisms that are in place to control the flow of sample in and out of that sampler. So it is very important to take measures that prohibit ice from building up within the line to prevent these problems from happening. The next subject relates to the collection bottle. So how do we prevent sample from freezing within the bottle? Again, the degree and duration that we drop below freezing has an important factor on the level of risk. Is the sampler itself in a fully exposed location? In other words, it's subject to the entire brunt of cold freezing air. Is it in shade? Is it exposed to wind? That becomes an important factor because wind will remove heat at an accelerated rate. If it's in shade, there will be no solar heat potential. In some cases, customers will use an insulation wrap around the body of the sampler, kind of call it a sampler koozie. They may position the sampler within a larger enclosure that's insulated. And if the conditions are severe enough, that enclosure may have a heater of some sort. Now that heater need not be a hefty 50,000 BTU heater. It just needs to have enough heat to prevent the sample area from dropping below 32 degrees. 1 or 2 degrees above freezing is more than sufficient to prevent the sample from freezing within the container. There have been cases where folks have overzealously put too large of a heater in the unit and actually created a situation where plastic components of the sampler have melted. So be very cognizant of the amount of wattage that a heater has that you may be using. I've also had customers that have utilized heat packs. but be very cognizant and cautious of the amount of heat that is being induced into the area, because that could impair the sample integrity if it gets too warm. The cold weather impact on power sources. Do cold temperatures affect the power consumption of charging capacities of NiCad batteries? Some batteries perform well at low temperatures and some do not. For example, NiCad batteries, which are mentioned here, will perform better at cooler temperatures compared to lead acid batteries. The sampler itself will have elevated current draw, as the cold air will make the tubing stiffer within a peristaltic pump, and thus this will place a greater load on the pump motor and draw greater current. Lubrication grease on the gears will be more viscous as a result of being cold. That too will create and add to the load of the pump motor. So cold weather can have an accelerated and elevated current draw from your battery source. Cold weather impact on the electronics of the controller. What special measures should be taken for the controller? Well, there are temperature limits for any device, any sampler controller. So the first thing is know what those limits are for that given device that is in use, and determine if we are at risk of reaching or exceeding those limits in the environment we are using the sampler in. Generally speaking, issues are not binary when it comes to cold weather and sampler controllers. In other words, it's not going to work perfectly and then at some point in time everything's going to fall off the face of the earth and stop operating. There are gradual impacts. The first impacted area of a sampler controller would relate to those units that are utilizing LCD displays. If the expected conditions in the ambient area of the sample are expected to exceed the limits of that controller, we may need to implement similar measures as we would with the collection bottle to again prevent the sampler controller from being exposed to those low temperature values, insulation, enclosures, heated enclosures. What impact does the cold weather have on the controller? Well, as indicated, the LCD display will often be the first area impacted. An LCD display does have temperature controlled contrast, so as the ambient air around the sampler either elevates or decreases, it adjusts the contrast of the display accordingly to maintain the ability to easily read the display. In cases where the sampler has transitioned from a warm environment to a sub-freezing condition, the internal air within the sampler controller being sealed could compress, and as a result that can pull down any labels that are over the keypad and have some impact on the keypad response. There are low temperature limits again for the sampler controller, so if you know what those limits are and you know what conditions the sampler is going to be exposed at a given location, again, take the measures that we need to maintain the sample temperature around the sampler above those limits. I've noticed cold temperatures on the LCD screen sometimes results in very faint and response to inputs is slow. Any suggestions for overcoming these issues? As indicated, the LCD display is one of the areas that will be impacted first by cold temperatures. An LCD display is a liquid crystal display. And I promise this is as technical as I'll get today. But an LCD works by a voltage being applied to a plane behind the crystal, the liquid crystal, that either aligns the crystals to allow light to pass through or randomize and block that light. When those crystals are in alignment, the light passes through easily and you see the black background, i.e. the text, with ease. When those crystals are not in alignment, it just looks gray. When liquid gets cold, it freezes, and the liquid crystal within the display is no different. When that crystal becomes very cold and begins to freeze, it no longer has the ability to align when it's told to, and thus the contrast looks very low or faint. In extreme cases, the only real option to address an issue like this is that we should have an enclosure that is at least insulated and preferably heated to maintain the visibility of that display. Equipment installation questions. We received a question about how to access concrete shallow bored wells during the winter. There are a number of topics that we could talk about that go around that, but there may be some additional background to this question that would be able to provide a more complete and full answer. But a lot of the same conditions need to be considered. How much of the suction line is exposed? Is the controller exposed? Do we have a lot of snow cover that could impede us? Are we intended on doing real-time sampling? In other words, where we go out to the site and collect samples and pick the equipment up and walk away? Or do we leave the equipment in place to come back later to pick up the collected samples? Should I consider using a heater in conjunction with the sampler? Again, potentially yes. It depends upon the conditions that are we operating in. The duration and the degree that we drop below freezing have a huge impact on that. Again, if we do decide we need a heater, it need not be a hefty heater. We just need to keep things a few degrees above freezing. That's our goal. In the old days, it was not uncommon for folks to use a low wattage light bulb as their heater. A 10 to 25 watt light bulb would put off enough heat to keep the ambient air around the sampler elevated above freezing. Worth noting that LED light bulbs would not meet that need simply because they do not put off the heat. But just a low wattage heater. A 10 watt heater is more than enough. My refrigerated sampler has an internal heater and can operate to minus 20 degrees Celsius. Should I be concerned during weather above minus 20 degrees C? The answer to that question is yes. There is reasons to have some level of concern. Keep in mind that the external components are not aided by that internal heater at all. Our suction line is still exposed to the open air. Our pump is still exposed to the open air, although it's worth noting that some sampler models out there do have the ability to add a heater to the pump. There are several caveats with internal compartment heaters that need also to be considered. And this ties very closely to the location of the sampler. A sampler positioned on a north-facing location that is shaded in a location that has elevated winds at minus 10 degrees Celsius will be more at risk of issues compared to a south-facing sampler that is in full sunlight with no wind at the same ambient temperature. With the former, again, the heat is being removed at an accelerated rate compared to the latter. So even though that heater is in there, the ambient conditions that exist around the sampler could diminish the ability of that heater to keep the elevated temperature above freezing. At what temperature should you start to worry about your pumps freezing? And more accurately, it would be about liquid freezing in the pump lines. When they are sampling in manholes about 40 feet down, we start using hot hands to keep our samplers warm when the temperatures reach 20 degrees. Do you have any other suggestions? Again, similar as above, this isn't a black and white issue. It's just not how low the temperature gets, but how long it stays there. In most cases, within a manhole, the temperatures again will maintain a measure of elevation above the outside air, simply because there will be heat rising off of the flow below. There will also be heat from the surrounding ground around the manhole stovepipe. Obviously, when the sampler is being serviced, such as bottles are being exchanged after a sample event or other purposes, changing batteries, whatever, the sampler will need to be removed from the manhole environment for that activity. And if the ambient temperatures are extreme, there could be some impact while the sampler is being exposed to those temperatures, such as the LCD, again, could become faint and more difficult to read. Can condensation cause the fuse in the battery cables to be replaced more often? I think there's probably more behind this question than the basic indication. Generally speaking, no. If you're in sub-zero freezing temperatures, the amount of condensation is likely to be fairly minimal. Condensation generally will occur if you move from a cold environment to a warm environment where the ambient humidity is at an elevated rate. And when that ambient air is in contact with the cold sampler surfaces, it will have the tendency to condense, not unlike our beer cans in the middle of summer do. Well, if that condensation occurs at certain critical areas like open connectors, there could be some impact. But keep in mind that the sampler controller itself is a sealed case. So the sampler controller itself should be fully protected from moisture intrusion. Generally speaking, questions that relate to fuse more likely indicates that fuses are blowing. And at least in my mind, this sounds like there is something at hand that's more than just mere condensation. Fuses blow if the current that they are asked to deliver or pass through exceed the limits of that fuse. Condensation alone in the fuse holder or around the fuse would not likely cause the fuse to open. Now, condensation that's past the fuse, that may be at a location that impacts the power and the ground connections that would create a potential path for current, that could cause the current to elevate and thus exceed the limit of the fuse. However, that is not likely again to occur in sub-freezing conditions because the ambient humidity in sub-freezing conditions is very low. My channel occasionally freezes. Will that create problems? Well, it depends. If we just have a situation where we have a buildup of ice on the surface, but the liquid below the surface is still in a liquid state and flowing, and the sampler intake strainer is positioned below that surface ice, the unit is likely to be able to collect samples just fine, and there will be no problems. However, if that channel freezes solid, absolutely it would create some problems, because the sampler would be unable to pull in a sample. While this would place a strain on the pump, akin to any blockage condition that could exist for whatever reason, that alone would not result in any damage, but just failed samples. However, if a chunk of that ice did get pulled in and made its way up to the pump, the risk would be the same as if we had ice building up within the suction line, and that ice gets pulled into the pump. And in the case of a peristaltic pump, if the roller comes down and chomps on that piece of ice, that's at risk of creating a lot of problems, because the pump's going from full speed to zero in a fraction of a second. That could damage teeth. It could, do other damage like shear the bolt that the rollers are held onto the pump shaft. It could cause some motor damage. If it didn't cause any of those, it definitely would cause the unit to go into a pump jam state. And at that point, the sampler will cease attempting to collect samples because it knows something serious has gone on. So if we have an application where we are at risk of the channel freezing solid, one would have to, assess the risk of, on one hand, what's the importance of collecting samples from this site, knowing that we may have a inability to collect samples at that site, versus the risk that we're placing on the sampler controller of damaging it as a result. And with that, that is the end of the questions that were submitted in advance. And at this point in time, I would like to open the floor to any questions that you may have. And as Sharon indicated, please utilize the Q&A function of Zoom to submit those questions, so that we are able to log those questions in the event that we do not get to them all today, and therefore afford the opportunity to respond back to you directly at a later point in time. With that, I open the floor.
Well, thank you, Steve. And as he just mentioned, please submit your questions through the Q&A function within Zoom. I would also like to thank both Steve and Bob for providing this informative presentation. Steve, if you can open with the first question.
Thank you, Sharon. And I do reiterate that please submit whatever questions you may have. There are no questions that we will refuse. We promise not to laugh. And anything that you can provide question-wise would be benefit to not only you, but maybe the larger audience, and we welcome them. The first question that was received, you stated about heater options for the samplers. What would you recommend? Well, the thing that comes with the heaters is certainly there's a power penalty involved with any heater device, because the heater is going to be drawing a certain amount of juice to enable it to do its job. In many applications, heaters are, or many samplers, I should say, are battery powered. So the idea of placing an additional draw in such a condition on a battery is probably something that needs to be given a second and maybe a third thought, because while the heater may be able to maintain, at least for a period of time, that elevated temperature we're looking for, the risk is that it will prematurely drain the battery, and that will cause the unit to fail to collect samples. So when you're dealing with a battery powered application, be cognizant that you have a finite amount of power, and given the choice between the heater and the sampler, the sampler is probably the more critical component. The heater obviously is an important component as well, because we're intending on maintaining our temperature elevated above freezing to prevent, ice from forming. But at the same point in time, that accelerated current draw of that heater is likely to have a very negative impact on the amount of battery power we have available for the sampler. So keep that in mind when you're, considering heater. Now, if we're dealing with an AC powered site, obviously power is not that big of a concern. So we have a little more freedom, if you will, regarding our selection of heaters. And as indicated prior during the body of the presentation here, we don't need to have a very high BTU level heater. All we need to achieve is just to keep the ambient air around the sampler a degree or two above freezing. The next question we have here is, what type of insulation is recommended for wrapping the samplers? We don't have any specific recommendation. However, generally speaking, you go to Home Depot or a similar home store like that provides construction supplies. Pipe insulation is very common, especially in colder climates. When you get to some housing that may have exposed pipes below, obviously mobile homes would have this particular need, where you can just get pipe insulation. It's round, it has a slot down the side where you just push it up and over the pipe. And in this case, you would push it up and over the suction line. You can use wire ties or even tape, if you will, to close it and clamp it around the suction line so that it is insulated and sealed. And oftentimes, again, if we're in more moderate to low risk locations, that insulation coupled with the heat, that the flow itself that's being drawn up and discharged out, will have a sufficient amount of insulating properties to prevent ice from forming in the line. Now, if we're dealing with extreme conditions where we're dropping, sub-zero, single digits in Fahrenheit, that is when we may want to consider some sort of active method like heat tape. Again, this is something that can be purchased at a Home Depot or similar type store, and typically its application again would be to maintain temperature for water pipes in a house or a mobile home to prevent freezing from occurring by actively heating the pipe. For the heater, can you plug it into the sampler? Well, on one hand, I guess you could. However, the better avenue would not be to have the power required for that heater pass through the sampler in the first place, because that could be, creating some potential issues within the sampler depending upon the level of wattage of that heater. But in most cases, you would want to have, for battery powered applications, you would probably want to attach the heater directly to the battery. And if this is a AC line powered application, you would just plug it directly into the outlet. The next question I have here: most of the time our sampling is done during non-winter conditions. However, when we had to do it, we covered the sampler and manhole area up with a tarp. It worked quite well, but would like your thoughts on that approach. That's a perfect approach. Again, as it was indicated earlier, there is a level of heat that is, coming up from the ground, from the sewer line that's, down below the manhole. When I say heat, it's all relative, because if you have 40-degree air coming up from the manhole into an ambient area that's 12 degrees, you still have heat. And the tarp being over the sampler and over the manhole area would trap that heat in the area around the sampler. So that's a fine approach, especially if it worked. I've said many times over the last 38 years that experience is the greatest teacher. And if you've found a method that is relatively easy to implement and it works well, always remember that and use it again when the need arises, because again, experience is the greatest teacher. And if in your experience that worked fine, there's no reason for me to recommend otherwise. The next question I have here, I have a solar battery setup for my Avalanche samplers. I am continually having my batteries drawn down to 7 to 9 volts on a 12-volt deep cycle marine battery. I suspect that it's my regulator, but not sure. Could the modem be drawing power down? Does leaving the solar exposed to the sun without hooking up the battery fry the regulator? Would it fry the regulator in a matter of seconds? Well, there's a number of questions there. Some of them are in the area of the topic at hand. Some of them are a little outside of it, but that's not a problem. First of all, regarding that Avalanche sampler, it does have active refrigeration. Depending upon what the exterior ambient conditions are, meaning how often is that refrigeration system being called into use, definitely that could have an impact on that battery level. And obviously, the warmer the ambient air is around the refrigerated unit, the more it needs to run. The more it runs, the greater the impact is on the amount of capacity being drawn out of the battery. Now, there are other things there that could be in play. Sampler configuration selections can have an impact on the amount of power drawn out of that battery. For example, if you have the backlight for the display active, that will have a tremendous impact on the draw out of the battery. With that backlight on, it's drawing in the neighborhood of a constant current of 300 milliamps. So if you're in a battery powered application, number one, keep the backlight off. It's not stated here, but there could be measurement devices associated with that sampler as well. Depending upon certain configuration settings, such as your measurement interval or logging interval, that could have an impact on the amount of power being drawn out of the battery and the rate at which it's drawn. If you're taking measurements every minute, that's going to draw 5 times the amount of power as taking measurements every 5 minutes. It also has an impact on what those devices are. Is it a bubbler? Is it an area velocity? Do we have SDI-12 devices? There's indication that a modem's in the play here. And as a result, yes, that modem configuration can have a huge impact on the impact of how you're drawing power out of that battery. If you have that battery or that modem set up to continually be actively looking for incoming phone calls, that modem's going to be drawing power on a constant basis. Whereas if you have that modem set to periodically check for incoming phone calls or incoming connections, that will have a dramatic reduction in the amount of power that it uses. Now, if you have a solar panel connected but you're not connected to a battery, that's not going to have any impact on the regulator, because there's nothing on the other end of that regulator to draw that power through. So I would suspect if we have a properly designed regulator, that risk is almost non-existent. There are a couple of questions here that were submitted via the chat function. And again, I reiterate, please submit questions via the Q&A function so that we can log those questions in the event that we're unable to get to them today. And that enables us to still get back to you after the fact. There's a question here. Let me see. That was submitted via the chat. I joined late. I like to set up samplers on Friday and delay the start until Monday morning. Assuming a 40-degree environment, what type of amperage can I expect after 3 or 4 days? Or more specifically, how much draw out of the battery? Well, there's some caveats to that question that would need to be understood to more accurately answer that question. If it's just a sampler alone, let's just say it's for lack of a better word, or a better description, just a 6712 sampler with no add-ons, no other measurement devices on the system, no SDI 12 devices, no modem. The current draw is going to be fairly low. It'll be in the neighborhood of a constant draw of somewhere between 10 and 15 milliamps. So if you just do the math on that, we're talking relatively low current, just sitting there doing nothing until we hit Monday morning, when of course the active sampling begins and now the pump is active and drawing a lot more current. It's also not stated what type of battery we're using here. That is also something that needs to be put into the equation. A NiCad battery just sitting there not in use will draw somewhere in the neighborhood of or decrease somewhere in the neighborhood of 1 to 2% doing nothing. So a NiCad battery, if that's the case here from Friday to Monday, would lose somewhere between 4 and 8% of its capacity just sitting there. Then you add the current draw of the unit, the base current draw on that. So you could be down to 80% of your capacity come Monday morning when the sampler triggers in. Not considering the winter conditions or anything like that, always be cognizant of the size of your battery versus the amount of power that you're going to require of that battery for your sampling application. Generally speaking, if you're putting a sampler out for more longer duration deployment, we generally will recommend larger capacity batteries, marine batteries that are in the 100 amp hour range. There's nothing wrong with having more power available than you require, but there will never be anything that's good results when your battery capacity is at or below what your needs will be. So you can never go wrong with a battery that's in excess of what your needs are going to be. There is a question here that's kind of a follow-up question about the solar panel and so forth. And again, this relates to the Avalanche sampler. It says this is happening when my sampler is in idle mode, not refrigerating or sampling. There could be a caveat here that would be worth exploring in. The Avalanche sampler does have, as part of its code design, measures that will increase the efficiency and decrease the current needs when properly used. But if not properly used, that could go unnoticed. So for example, if I start a program that's either going to start immediately or at some unknown future point in time, because it's being triggered by some criteria such as certain depth in the channel, certain rainfall, whatever, the refrigeration system is dormant. Even if the sampler were triggered into operation, that refrigeration system is still dormant and not drawing any power until that first sample is collected. Once that first sample is collected and delivered to the bottle with inside the compartment, the Avalanche sampler knows now it has sample that it has to cool, and therefore able to retrigger the refrigeration system into operation and begin to have that elevated current draw. When that happens, that refrigeration system therefore remains active, and again, depending upon the ambient conditions, will have an impact on the duty cycle of that refrigeration system, which could mean even more elevated current draw if we're in elevated ambient temperatures. Even after that sampler program is completed, that sampler still believes it has sample to cool, so it will continue to run that refrigeration system until a new program is initiated, a new sample collection routine is initiated, which begins that whole cycle all over again of placing the sampler into that dormant state for the refrigeration system, where it has reduced the amount of current being drawn by the system, again, until that first sample is collected for that next routine. Now, the other caveats again around that question could relate to the modem or whatever other devices we have associated with this particular system, because there are current needs of the system beyond the refrigeration system alone. The modem, any other measurement devices, the data rate measurement interval, those can all have impact. The backlight, those will all have impact on the current draw. So every one of those caveats should be understood as part of that question when trying to figure out where I may be able to implement means to reduce the amount of current being drawn from my battery. I believe that is the end of the questions at this point in time. So if there are any other questions, we'll kind of do the auctioneer approach here and say going once, going twice, and sold. Again, if there are any questions that come to mind, at some later point in time, I welcome anyone to submit those questions to me via my email address that you see on the display there. And I would appreciate those questions. And with that, I'll turn it back over to Sharon.